Good morning, everybody. Can you hear me?
Yes, I can hear you.
Thank you. All right. Well, first things first, in accordance with my syllabus, I do require that people enable their video. And in the future, if you can't enable your video for whatever reason, I want you to send me an email prior to class. The reason I ask people to enable their video is to provide a little bit more accountability. Last semester, I didn't require it, and it appeared because I would ask people questions that they weren't even at their screen. All I saw was the name on the screen, and I just couldn't really tell if they were engaging or not. So I say, if you're going to be here, I'd like you to enable your video, please. All right, and if it's a temporary reason, like your webcam's out or whatever, then let me know, and we'll make arrangements from there. Okay, thank you very much. Okay, let's go take a look. I'll share my screen here. So as you can see, well, if you're here, then you must have found the link to the meeting. Otherwise, you wouldn't be here. All right, let me see how many people here we have. All right. Okay, let me go back to where I'm going here. Right. So you can all see my screen, is that correct?
Yes.
Yes.
Thank you. Okay, so we're looking at, this is a live online class, which means we do have scheduled class times. I'm expecting people to turn up to class, but it's not going to be mandatory that you do so. I usually found last semester that I was getting maybe 1/3 to maybe 1/2 the class turning up at any given time, sometimes less. I do record the meetings though, and I put them on YouTube, and then I put the link in the Zoom folder. So I think what happens is often people won't attend class, they'll have good intentions of watching the video, but sometimes they simply don't. But that's okay, as long as you are keeping up with the work and keeping up with the exercises that I suggest you do. And I'm going to also now just go through the syllabus and just let you know exactly what's going on with the class. To get the most out of the class, I do recommend that you attend class or at least watch the Zoom sessions at the bare minimum if you can't attend. So I've got my phone number here. This is a cell phone number. It's a Google Voice number, and I'll answer it during my office hours, which actually I haven't set yet. My office hours will be under this link here, and I will update those probably sometime today. But you can call this number during my office hours, and I will answer as long as I'm not on the phone with somebody else. If it's not during office hours, I'll try and call back as quickly as I possibly can. Let's see. All right, I've already talked about attendance here. So it's your responsibility to make sure you get your homework, the quizzes done that need to get done. And you can see my live online video requirement here. That's what I was talking about. All right, so let's go through and look at the assessments and what you're doing here. Does anybody have any questions so far? Okay. So for testing, we got test 1 and 2 are going to be a combination of my courses quizzes and a test administered, in this case under honor lock, since we're doing online here. So the homework for test 1, what you'll need to do is you'll need to do these exercises, and these are the points that each of these exercises are worth here. as you go through and do them. So this is how you'll know exactly what you need to do. And also by looking at the grades tab as well, that will be helpful in determining what needs to be done and what you have done, what you haven't done yet. All right, so let's take a look at, we'll take a look at test 1 folder here. So this is all based on my survival guide, and the survival guide is actually sort of in each of the modules here. So if you go through modules 1 through 6, I've got the soft chalk exercises and the PDF document, which is the module from the survival guide. And the soft chalk here, I'll show you an example here of the soft chalk. It's pretty much what's in the survival guide, except that along with that, it's got these interactive exercises that allow you to test yourself while you go through it and read it. So that can be a good way to certainly review. I mean, I'm expecting for a lot of the stuff in test 1 and 2, you would have seen it before, either because you've had high school chemistry or because you've done introductory chemistry, Chem 1025. So let's take a look at one of the module folders and you can get an idea of the kinds of assessments that you're going to be doing for test 1 and 2. So you've got the module 1 assignment, and then you need to get 80% on that, and then that will open up the module 1 practice quiz, and you need to get 80% on that, and then that opens the module 1 credit quiz. Now the module 1 assignment, there's going to be video tutorials for every single problem that appears in that assignment. You can do that assignment as many times as you like, until you get 80%. And if you're having trouble with any of the questions, you can always look at the video tutorials, which goes through exactly how to do those questions. This is the same for all of the, all the modules that you'll be doing in test 1 and 2. It's going to be the same kind of pattern. You'll notice that these all end on February 7th. So the test is actually going to be due on February 8th, but this is all homework. It's actually 4 credit, it's worth 20%. And that will be due on February 7th, so the day before the test is due. Now the test is actually due, let's have a look at the test here. This is under the test 1 part here, if I can find it. There we go. Now, I don't know why. Okay, I need to enable that for honor lock, and I will do that pretty soon. I've forgotten to do that, but you'll notice that there's an end date on it, but there's not a start date, which means that you could do test 1, and much earlier if you want to. There's no real need to wait until the last day to do it. Most people do wait until the day it's due to do it. I think it's better to do it early. I would do it before the homework is due, actually, just to make sure you get it done. That would be my thought. But as I said, I will enable this for honor lock pretty soon. Now, as far as honor lock goes, most of you have probably used it by this point. If you haven't used it, I've got this honor lock practice test and video here that will allow you to get an idea of what's required and how to set it up and make sure that you know exactly what you're doing before you go in and take a real test. Does anybody have any questions so far?
I do have one question, and just because our first section is about the periodic table. Mm-hmm. Are we allowed to use P table during these things just to get like the most realistic periodic table for how to find molar mass? And
are you talking about for the actual tests?
Well, yeah, because my last chem class, like if we needed to find molar mass, we're allowed to use P table, an online periodic table that was interactive. I don't know if that's allowed in this class.
Well, it won't be during tests, but let me show you what the tests are going to be looking at here. So this sample module 1 to 6 test is actually the same test that you'll be taking. So let me show you an example of this. And what you'll see, and the reason I'm sort of bringing this up now, I'm going to preview it. So this is the same test as you'll be taking, this the same one that you'll be taking under honor lock. You can take this as many times as you like. As you can see, I've got a periodic table already in there. So that's the one that I would want you to be using. I mean, during the course, you can use p-table as often as you want, but during tests, you'll definitely need to be using the periodic table I supply to you within the actual test itself. So this sample test that I'm giving you is set up exactly the same as the real test that you'll be taking. And you can take this as often as you want to practice for it. I mean, I could not be more transparent as far as that goes. Now, if you're having trouble actually reading the masses, what you can do, I'm on a Mac, so I'm going to do Command+. And you can see that enlarges it. On a PC, you use Control+. Control+, Control-, Command+, Command- in order to increase the size of the screen or decrease the size of the screen. So zoom in, zoom out. So that makes it a bit easier for you. The other thing is that I'm requiring that you use the honor lock calculator. And it's a little bit of an annoyance, I know, because most people like to use a handheld calculator. The problem is that neither I nor honor lock can tell the difference between a handheld calculator and a cell phone. So you'll need to use the on-screen calculator. And you can see this is an example of it. Take it back here. I'll open it up in a new tab. Open like a new tab. That's better. And what you can do is you can actually pull the tab out and have it next to your test. And I'd recommend doing that in order to practice. On the real test, it's not so much a link. You'll see it's a button that opens up the calculator. All right, does anybody have any questions so far? So as I said, and this is the amazing thing, let me see if I can, I thought I could, let me see if I can exit this, just get out of this. I can't get it, I'm going to submit it to get out of it. All right. So going back to this test one folder here, you can see that you've got this sample module 1 to 6 test, which is actually the same as the test you'll be taking. It has unlimited attempts and it doesn't close. Now, test 1, as you can see, closes February 8th, and the homework also closes the day before that. There's also the opportunity to get some extra credit, and you can do that by getting 80% on the sample module test, 80% before February 7th. If you do that, you get an extra 5 points. You know, that's, and you'd be amazed, you know, what I find is that in a class of 40 students, I find that maybe 16 people do this. I don't know, the other people, the other 24, and I guess they just don't like 3 points. I don't know what it is. But you know, maybe you guys can buck the trend and have everybody do the extra credit. I don't know why people don't take advantage of it. I mean, come on, this is the test that you're actually going to use as study for the real test because it's the same test. Why wouldn't you do it and get 80% on it? I don't get it. I just simply don't get why people don't do it. Does anybody have any questions?
Can you hear me?
Yeah, I can hear you, Tyler.
Okay, thank you. Still trying to work out the video issue.
Yeah, okay, fair enough. Do you have a question?
No.
Oh,
Just
okay.
checking on that.
Okay, fair enough. Thank you. Does anybody have any questions?
This is actually gonna sound kind of stupid, but in intro, I just was wondering how like many questions your tests usually are. I know it's kind of.
Well, the thing is that if you look at the sample test is going to be the same as the test you'll be taking. So, you know, you'll be able to tell by doing the sample test. And I would just recommend taking it over and over until you, that's the thing, if you can get, say, 90% on the sample test after you've taken it, and you're doing it, say, closed book, like you would be on a regular test, then I can't see how you can fail. It's impossible. I honestly don't see how anybody can fail. I'm sorry, Stella. I'm not sure I answered your question though. Now I'm looking at it. So did I answer your question?
Yeah, no, you did all right. I just was I was wondering if the sorry, I have brain fart. If the test that you just showed us, if it was running, because I took you for intro chem and your tests were short. I'm not gonna say that I didn't love that, but I was wondering if this one was just running longer because it was like the two combined, you said? Yeah,
I'd say that's probably true. And the other thing is that I look upon it as being reviewed too, because you've all seen most of this before.
All right, thank you.
All right, no worries, Stella. Any other questions?
Yes, I have a question.
Yes.
Do we get to use the reference sheets?
The reference sheets are inside the test.
Okay.
So I'll show you what I'm talking about. I'm going to open up this test again and you'll see what I'm talking about. So I showed you the periodic table already. But you can see that as you go through, there's the reference sheet for the for the conversions, right? And we go through, and there's your polyatomic ion sheet, another periodic table. And the solubility chart. So it's all in the actual test. And remember, the real test is the same as the sample test.
Okay, thank you.
I don't know. I don't understand why people fail this course. I don't. It's beyond me. I mean, I couldn't be more transparent. How many courses have you done where you get to take the test as many times as you want before you take the real test and it's the same test? I can't believe that there's too many courses you've taken where that's true. And yet I still have people fail the course. It just doesn't need to happen. It just doesn't need to happen. I'm here to help. You've got my phone number. If you have any problems, you can always call me during office hours or even outside my office hours and I'll call you back. You can text me as well on that number. I don't usually get too many texts, but you can text me on that number. Does anybody have any questions? All right, let's go back to the syllabus here. Actually, before I go to the syllabus, let me show you the grades. I'm going to view as a student here. I'm going to show you something here. It's really cool in the grades section. So you all have a grades area. And this is what it's going to look like to you. So in the test 1 portion of the grade book, you've got all the homework here and you can see exactly, you'll be able to see exactly what you've done and what you haven't done. If you've got a 0 there, chances are you haven't done it. It'd be pretty unbelievable if you did it and got 0. So I don't think that's going to happen. But you can look here and see, oh, anything with 0, oh, that's something I haven't done yet. See, it's all very, very transparent. Look at that. So same for test 2. Now test 3 is a little different, and test 4, because you'll just have the test and then everything else here is extra credit on test 3 and 4. This actually isn't homework, stuff that this is stuff you don't have to do, but you'd be crazy not to do it because it's all extra credit. And all of that is due the day before the test is due as well. So just to clarify here, test 1 and 2 do actually have homework that you can do, but you also get 5 points of extra credit that you can do by doing the bonus getting the bonus for the module 1 to 6 test, just getting 80% on that, the day before the test is due. And, that's how you can make up for some homework you might not have done, for example. Does anybody have any questions about the grade book so far? Now, if you want to figure out what your grade is as you're going through the course, what I recommend is you look down here at the letter grades. I've got these letter grades here at the end of each test, and that will let you know how you're doing in the course. And there's a lot of other stuff on here, the points needed on the final to get an A, B, or C in the course, and all of that. All right, does anybody have any questions? Okay, let's go back to the syllabus here. All right, so I've been through test 1 and 2, and as I said, this has homework associated with it. Test 3 and 4 have the extra credit associated with them, so there's actually no homework. And all of that is due 11:59 p.m. on the day before the test is due. So here's the grading, just clarifying exactly what I had. Homework for test 1, 20%, 80% for test 1, and then you've got your sample test extra credit as well on top of that. So that's the same for test 1 and 2. And then test 3 is going to be test 3 plus any test 3 extra credit. There is a little bit of a condition on the extra credit. You don't get the full point, you get half whatever the aggregate is, or the sum of those. Yeah, I want to make them worth each half a point, but I can't do that in my courses. So I'm stuck with giving a full point and then dividing everything by 2 at the end. So that will sort of explain what you're getting there. Does anybody have any questions? All right, let's talk about how you're going to get the grades you want in the course. So when you're looking at the scores here, the scores are the full scores for the entire homework, extra credit, or anything else that you're getting with the tests. And as long as you get more than 90 on all 4 of those, then you can exempt the final with a grade of A. If you get more than 80 on all 4 tests, then you'll get a B without having to take the final. And then you can always take the final in order to improve your grade. If you have a B, then you can't lower your grade by taking the final either. So taking the final is optional as long as you scored at least 80 on the first 4 tests. If you score any less than that on any of the tests, you definitely will have to take the final. So the test grade that you're looking at after test 4 is based on your lowest test score, not the average of those scores, but the lowest test score. This often causes some confusion, especially around test 4 when people are looking to see if they can exempt the final, but it's all based on the lowest test score, not the average. Because I think if you're going to be able to exempt the final, then you had better have gotten that grade on all those tests. So if you exempt the final from A, you need to have gotten an A on all 4 tests. That's the way I see it. So all of it is calculated in your grade book. You actually don't have to do any calculations. It's all there. It's very comprehensive. All right. This is the schedule, and you can see that the resources, I would expect you to be looking at the soft chalk. So the idea is that I'd really like you to look at these before the class. And you can see the schedule here, how it's set up, and when the tests are due, when the homework is due. It's all very clearly laid out here. And these links here are to videos, and there's videos for pretty much what I'll be going through in the class as well. I think it's good to watch those before the class too. That's for test 3 and 4. All right, does anybody have any questions? Anybody have any questions at all? So the reason that I think people sometimes don't do well in the class is, well, I think it's going to be an obvious one, is that people leave stuff till the last minute. You know, they don't do anything. They don't attend class, they don't attend, they don't do any of the homework at all. They wait until the very last minute to do it. And of course, they end up not doing well. So if you look at the student responsibility section of the SPC website, the thing that you need to realize is that if you're taking a 3-credit course, then you'll need to be spending at least outside of class, at least 6 hours doing stuff that's class related. How many people actually do that? I'd say not very many. But we're talking every week, not just the week that things are due. We're talking every week. You should be working 6 hours on this course. And if you're not doing that, and if you're failing, then it's pretty obvious why. The course itself isn't hard. This material is not hard. None of it's hard. But if you don't do the work, you'll fail. It's as simple as that. But work steadily throughout the course and you will reap the dividends. Does anybody have any questions? Nobody has any questions, hey? You're all completely clear about how the course is laid out?
So test 3 and 4, are we still doing that face-to-face, or is that?
Yeah. I mean, I plan on being here every Monday and Wednesday at 9:30. I'm planning on doing real-time lectures. The idea being that, you know, you can ask questions while I'm doing the lectures, just like a regular class. Does anybody have any questions?
Wait, so I'm confused. He just asked, did he just ask if test 3 and 4 are going to be face to face? Are we going somewhere to take? Are we doing?
No.
we're doing
I think he was talking about the lectures.
Oh no, I was talking about that. I was talking.
Oh, you were talking about the actual.
Yeah,
I'm sorry. You know what,
test-
Joseph, I apologize. I misunderstood your question. No, test
I
3
think
and
you explained.
test 3 and 4 will be administered under honor lock.
Okay. Yeah, I saw paper tests. I'm like, oh.
No, that's just for the face-to-face class, right?
Oh, that's what that. Okay, I thought that meant it's a paper test being administered face.
No, that's for the face-to-face class. But
Okay,
online, test 3 and 4 are identical to practice test 3 and 4. These are administered under honor lock, need to be completed by the due date.
Oh, I should have read it online.
No, you're good. You're good. I get it now. So hopefully that clears it up. You okay, Stella?
Yeah, I was just piggybacking.
Yeah, that's good. No, it was I'm glad you said something, because I wouldn't want people to think they had to go somewhere to take the test. You don't. Does anybody have any questions at all?
For soft shock, do they show, like, if you get a question wrong, because I'm looking at it,
Yeah.
if you get a question wrong, does it show you the right answer after you finish it all, or is it?
No, I don't think it does. Actually, it might. It might. I'm not 100% sure of that. I think it does show you after you've submitted it.
All right. Thank you.
Yeah, but it's not for a grade or anything. It's just sort of to test you as you go. it will definitely tell you if you've got the wrong answer, I think, or the right answer.
Yeah, it tells you get it wrong. It just doesn't tell you
Yeah.
what the right answer is. It doesn't let you resubmit
Right.
to see if you could find it out afterwards.
Right. Maybe it might not too. It might just be a situation where you have to do it again to get the right answer. You know, to read through it again, to get the right answer, and then you understand it. Could be like that too. I honestly can't remember. I suspect the answers appear when you submit it. Now, any other questions at all about the course?
Professor, I have a question regarding the course's relation to the lab.
Sure.
In Chem, I was fortunate enough to take the same instructor for both. Semester, it's a bit different. So do all the lab courses, regardless of instructor, sort of keep pace with the lecture regardless of instructor?
We try and arrange that. It might not be perfect, but it's usually pretty close, that we're covering stuff that's similar to the lab generally, while we're covering the we've tried to arrange it that way. Yeah, everybody's pretty much doing the same stuff in lab though, regardless of their instructor. Pretty much, not everybody, but most people are.
I had that last term. They all stay at the same pace, but how they go about their tests are different.
Yeah.
Like I remember I had Professor Shuniak last term, and he allowed you. It was like completely open note on all his tests.
Yeah.
But Professor Wei didn't allow any of that on her test. So it's how you take the test is different, but they all stay at the same pace.
Yeah.
Usually.
Yeah. Usually. Yeah. You know, it's up to them how they administer it.
Thank you.
All right, any other course-related questions? All right, so I do see a bunch of people who don't have their video enabled. Now, this is some of you might have come in a little bit late, but this is something I do require. If you're going to attend class, you are going to have to enable your video. And occasionally I'll be checking to make sure people are. And the reason I do this is to make sure that people are going to be engaged during the class. There are a lot of reasons people don't want to show their video, but most of them aren't very good reasons, to be honest. Some people like to multitask and believe that it shouldn't matter whether I can see you or not. And some people don't want to show their environment. I would just say clean up your environment. Whatever's going to be on camera, just clean it up. If you're going to be embarrassed about what's behind you. So you don't have to enable your audio. So if you've got a lot of noise, dogs and whatever going on, then you can always do that. So there are going to be times, I know, when people are not able to show their video. One example is I remember somebody in another class, they said, well, yeah, they're on a road trip or something, they were driving, they wouldn't be able to show their video that day. That's fine. Just email me, let me know that you won't be able to show your video that day. Sometimes people's cameras go out and they need to wait for another camera to come. Yeah, that's okay too, but it better be temporary is all I'm saying. So it's pretty obvious here who's got their video enabled and who hasn't. I'll always know. All right. So email me if you can't show your video, and give me a good reason for why not. Okay. Does anybody have any other questions about the course? Anybody, any other questions? It's good to see I've got 37 people here. That's excellent. I appreciate all of you coming today. That's good. All right, well, I will get started on Module 1 if nobody has any other syllabus related questions. Anybody have anything?
Oops.
Speak now or forever hold your peace. Tyler, do you have something?
No, it's all
No.
laid out right there for us. I think it's pretty straightforward.
Okay. No, the thing is, and this is what I try and do, I try to be as transparent as possible. It's going to be very difficult for anybody to come up to me later and say, well, look, Dr. Musgrave, I'm sorry, but you know, the course wasn't transparent enough. I didn't know what I had to do, or I didn't know I didn't know what the tests were going to look like, and I think it was really unfair. People just don't do that. If they fail, it's because they didn't do the work. It's really that simple. It's not because the course material was too hard or anything like that. They simply didn't do the work. It really is that simple. Do the work, you'll pass the course. Make the effort, you'll pass the course. Okay, well, we'll get started on module 1 then. Is anybody unclear about what they should be doing each week? Anybody have any problems with what they should be doing each week? Well, just to sort of reiterate, what I would do is when I've covered a module in class, you should be doing the homework for that module. So I'm going to do module 1 today. You can do module 1 homework today. You can work ahead too if you want to. I'd strongly recommend that as well. But at the bare minimum, you should be doing the homework as I cover it. That way, you don't have to wait until the very end. All right, let's look at module 1. All right, let's first of all talk about the composition of the atom. And I'm not going to spend a whole lot of time on this. But if you've got the number of protons, it's going to be the atomic number. Of course, it's going to vary from periodic table to periodic table where these things are, but it's usually pretty obvious. The atomic number is going to be the way that they're ordered, and that's going to be the number of protons. Then you've got the symbol, of course. Now you've got the mass number here. Now the mass number is the protons and the neutrons in the nucleus. And in the nucleus, that's pretty much all you've got is protons and neutrons. And around the outside, you're going to have electrons. And in order to keep everything neutral, protons, which are positively charged, and you've got electrons that are negatively charged, and those have to be equal. And then you've got your mass number here, which tells you the number of protons and neutrons. You'll notice, though, it never is a whole number. It's always something with a decimal on it. And that kind of looks weird. And you're thinking, well, why would it be a decimal if it's just going to be straight numbers of protons and neutrons? And the reason for that is due to the concept of isotopes, which I have down here somewhere, which I'm going to give you an example of. Here we are. So in hydrogen, we got isotopes of hydrogen. All isotopes of hydrogen have one proton, but they have different numbers of neutrons. So we've got protium, which has 0 neutrons. We've got deuterium, which has 1 proton and 1 neutron. And then we've got tritium, that's the radioactive one, that's got 1 proton and 2 neutrons. So when you look at the average of all of these and you take into account natural abundance, that's how we come up with that number that is in the periodic table. The other wrinkle here is that this number that appears in the periodic table can vary from periodic table to periodic table, which is kind of annoying. It's not consistent. And the reason for that is because people have different numbers for natural abundance of the different isotopes. So they come up with different values on different periodic tables. It's a bit annoying, but what that means is when a mass is required, I'll always give you the masses or the correct or a periodic table to look at in order to figure that out. So that's how we deal with the inconsistency that can appear here with the masses. So to get the number of protons, we look at the atomic number. To get the number of neutrons, we take the mass number, which is of course both protons and neutrons, and we subtract out the number of protons. And here we just round it. So in the case of fluorine, it has 9 protons. It's got a mass number of 19, which means it's got 10 neutrons, and it's also going to have 9 electrons. Does anybody have any questions so far? Okay. The next thing we're going to look at is diagramming an atom. So if you had fluorine and you want to figure out the number of protons, neutrons, electrons, we already looked at that. The protons and neutrons go in the middle, and then the electrons go on the outside. Now, this model that I'm showing you here is called the Bohr, B-O-H-R model, named after Niels Bohr. And it's really a very dirty way, very quick and dirty way of showing energy levels. It's not exact. As we get to test 3, we'll get into quantum mechanics, which allows us to know a bit more about what's going on with the positioning of electrons and where they actually appear in space around the nucleus. You'll also notice that I have videos embedded within the soft chalk, and you can watch those for more of an explanation too. But what we find is that the number of electrons in these rows matches what we see on the periodic table. So let me see if I can pull up the periodic table here. I'm hoping I have one in this. I might not have one here. All right. Hang on. Yeah, it might not be one in module 1. It should be. But I do have one in the module 1 folder. There you go. So the number of electrons we have in the rows actually matches what's in the periodic table. So in the first row of the periodic table, we've got 2 elements. In the second row, we've got 8 elements. In the third row, we've got 8 elements. You just count them across. So you already have that knowledge right there just by looking at the periodic table as to how many electrons you're going to see in each row. It's not some sort of wild coincidence either. This is the way the periodic table is set up. It's matching what you're seeing in these so-called Bohr orbits that I'm talking about. So for fluorine, what you would do is, since we know we have 9 electrons, we put 2 in the first row, because there's 2 in the first row of the periodic table, and then the other 7 go in the second row. So if there happened to be, say, 11 electrons for sodium, for example, then what we would do is 2, then we do 8, and then we do a third row and put 1 in it. And that's how we manage it. Just look at the periodic table, which shows you exactly how many electrons go in each row. Does anybody have any questions? Now, I do say here that these are elements you probably should know the symbols of. Do you have to know them? No, not necessarily. I don't have, there's no questions in test 1 that require memorization of the periodic table. None, not one. But it does help, I think, to know these specific ones. The ones that are in bold are the ones that people tend to have problems with as far as spelling. In the parentheses next to some of these, I've got the Latin of the, or in this case, in the case of tungsten, the German, which is the origin of the symbol. So for potassium, it's actually kalium from the Latin, which is why it's K and not some sort of P or PO or PT or whatever. as you might expect. Does anybody have any questions? All right, so again, you don't have to memorize any of them. All right, we've already been through the isotopes. And I think you all know about the physical states of matter and categorizing matter. Well, okay. One of the ways we categorize matter is we talk about elements, we talk about compounds, and we talk about mixtures. Now, elements are just elements as they appear on the periodic table. So lead, sodium, helium, those are all elements. Now, compounds consist of chemically bonded elements, but these are pure. So sugar is C12H22O11. It's a whole bunch of molecules that contain a whole bunch of elements. But all that's required to make a compound is 2 elements. But compounds in and of themselves are generally pure. Yeah, just those things all bonded together in discrete separate molecules. Now, mixtures consist of 2 or more elements or compounds mixed together. So an example of that would be milk. Milk is a mixture. It's a mixture of compounds. It's a mixture of possibly elements as well. Generally, though, we don't have too many of those kinds of mixtures. Most of the time, it's mixtures of compounds. And we can have 2 kinds of those kinds of mixtures as well. We can have homogeneous, which is something where everything is, you can't see the components, like milk, for example, is a homogeneous mixture. You look at milk, all you see is a white liquid. You know it's a mixture, but everything is homogeneous. It's all one color. You can have a heterogeneous mixture as well. An example of that would be gravel. It's just a mixture of all sorts of different things, but you can see the components. That's how I tell the difference between homogeneous and heterogeneous. Does anybody have any questions? Okay, we can also talk about valence electrons. Now, I had talked a little bit about valence electrons. Let me take this back one page here. We'll see the one with the groupings on it. Here we go. So in this periodic table, it's got these Roman numerals above the groups, and these Roman numerals actually match the number of valence electrons. So what are valence electrons? Valence electrons are the electrons on the outer shell. So I was telling you before about how to diagram the electrons. So I'll go back to that. So you can see here in fluorine, this is an example of valence electrons. These are the ones that are in the outer shell. And those are important because those are the only ones that really can be involved in any bonding that goes on with other elements. These 2 in here are not going to be involved in bonding. Only these on the outside can be. And even then, not all of those might be involved either. So it's possible to have non-bonding electrons in the outer shell too. And we'll see that when we get to Lewis structures and other things like that. But in this case, you can see that fluorine would have 7, and it so happens, let's go back to that. It so happens that fluorine is in group 7. So that's how you can tell the number of valence electrons. Anybody have any questions so far? Okay. All right, let's get on to atoms and the ions that they form. Now, one thing we know about atoms is that they would all like to be like these guys here, the noble gases. And what makes the noble gases special is that their outer shell is full. Their outer shell of electrons is full. And generally, these are not subject to being involved in bonding. That's not entirely true. There are actually known compounds of krypton, xenon, and radon. And we'll get into that when we get into VSEPR and we look at looking at shapes and things. But it is possible to actually have compounds of these. But those compounds are not incredibly stable because these things would rather be on their own. And the reason is because they have what we call a full octet, which means they have 8 electrons in their outer shell. So when you've got something like magnesium, if you look at where it is on the periodic table, sorry about this, I hit the wrong tab. You see where it is on the periodic table, it's in group 2, which means it's got 2 electrons in its outer shell. Zoom thinks it's smarter than me. Come on. Move it down here a bit. There we go. So you can see that in order to get a full octet, it'd be more likely it would lose 2 electrons rather than gain 6. And if it loses 2 electrons, what happens is it maintains the number of protons it has, but the number of electrons has gone down by 2, which means now the net charge is positive 2. And this is because we've removed 2 electrons. And there's 2 protons in here that are no longer balanced by the electrons that used to be here. So the magnesium has now taken on a charge of 2+. We call this an ion. An ion is very simply a charged particle. Mg is not an ion. Mg2+ is an ion. So what we'll notice here as we go through this is that anything group 1, 2, and 3 will tend to lose electrons and form a positively charged ion because of that. Whereas things with 5 or more will tend to gain electrons. So an example here would be oxygen, which has 6 electrons in its outer shell, 6 valence electrons. So it's going to gain 2 electrons, and it's going to take on a -2 charge. Now, the reason for that is because we still have 8 protons in the middle, but now we've gained 2 electrons, and that means it has a net charge of -2, because electrons, of course, are negatively charged. So this can be how compounds are formed, especially what we're calling ionic compounds. So magnesium can give 2 electrons to oxygen, and that makes them both happy because now we've got Mg2+ and O2-, which becomes MgO. And this will form the foundation of how we name and form compounds. Does anybody have any questions? Okay, so in summary here, if you're looking at any element, if it's in group 1, 2, or 3, it'll lose electrons and become positive. If it's in group 5, 6, or 7, it will gain electrons and become negative. And so you might be wondering, why didn't I talk about group 4? Well, group 4 is kind of in the middle, and it usually doesn't, these usually don't gain or lose electrons, they usually share electrons and form covalent compounds rather than ionic compounds. So covalent compounds are a little bit different. In the case of ionic compounds, something's actually giving to something else. In the case of covalent, which I'm going to show you next, they will actually share electrons to get their octet. So fluorine, for example, if you've got 2 Fs, neither of them want to give electrons away, but they're happy to share an electron each so that they can get their octet. So that would be an example of a covalent situation. And in the case of carbon and things in group 4, you can see that those are going to be more inclined to share electrons rather than give or take 4 electrons in order to get their octet. We'll talk next, we will talk soon about how you can know if something's going to be covalent or ionic just by looking at its structure as well. We'll get to that though. And the last thing we can talk about in module 1 here is the 7 naturally occurring diatomic elements. So these are all gases, well, actually not all gases. They're all compounds that have, well, compounds that consist of 2 elements that makes them diatomic. But this is the natural form of all of these elements. So hydrogen is H2, nitrogen is N2, oxygen is O2. And then you've got all the halogens, F2, Cl2, Br2, and I2. So H2, N2, O2, and F2 are all gases, so Cl2. And Br2 is a liquid, and then I2 is a solid. So all of these are as a result of the covalent bonding I was just talking about, so that these can get their octet. I know hydrogen is kind of weird because it's just got 2, but that looks like helium. So it kind of does have a full outer shell, just like helium does. Does anybody have any questions so far? Okay. So that's all I wanted to talk about for module 1. Now you'll be able to do the homework for module 1. I'm going to get a start now also on module 2 since we do have the time. As you can see, I'm going kind of fast because I'm kind of assuming that you've seen a lot of this before. If you had any questions, you'd let me know.
Is the module 1 assignment T1? Is that the homework?
Yeah. Well, let's see. Let me go back. Hang on. Let me go back. Let me be real clear about this so you know.
And is the soft chalk graded?
No. It can't. Well, it kind of is as you do it, but it doesn't go for a grade in your grade book.
All right.
But the homework for module 1 would be the module 1 assignment. You can see down here. I'm still actually viewing this as a student. So what's going to happen is you'll take that. You need to get 80% on it, and then the module 1 practice quiz appears, and then you need to get 80% on that, and the module 1 credit quiz appears. So all you see initially is the module 1 assignment. All of this is made clear in the syllabus, tells you exactly what you need to do in order to get to the stuff that makes points. Okay? You won't see the stuff you haven't done yet, but it is all listed in the calendar.
Okay, thank you. Just making sure.
That's all right. Okay, so now I'm just getting out of student mode there. Okay, so module 2, we talked about some of this stuff already in module 1. So the way that the periodic table is laid out is we have groups which are analogous to those valence electrons I talked about, and that's the columns. And then the rows are called periods. So you can easily tell where the group is in the period for any element in the periodic table. So we can talk about group number, period, and energy level. And it turns out that period and energy level are really the same thing. So we've got, this is the first energy level, second, third, fourth. And that's related to that Bohr orbit thing that I showed you earlier. We already talked about valence electrons and how to find out those. All right, so let's look at the different regions of the periodic table. We've got what we call the transition elements. Those are all in the middle here. And then the ones on the outside we call representative elements. And the reason for that is because within those groups, pretty much all of these have very similar properties because they have very similar numbers of valence electrons. So they bond pretty similarly as well. So we notice the same kind of activity in each of those. That's why we call them representative. Transition elements, there's a lot more ambiguity as to what's similar to what. So we actually have specific regions of the periodic table that we can talk about as well. And these all have specific names. So these guys here are called the alkali metals. The ones that's in group 1. Group 2 metals are called alkaline earth. The transition metals are the ones in the middle. Then we've got the non-metals, and they're sort of over here, this little step thing. You often see this on periodic tables. little step thing here that shows you where the metals and non-metals are, or where they begin and where they finish. The ones near it are also called metalloids. I haven't got that listed here, but the ones that are kind of close to that transition, they kind of have similar, they can have mixtures of properties that are both metallic and non-metallic. These guys here in group 7 are called the halogens, and the ones over on the end are called the noble gases. So these are other metals here, and these are the non-metals here. Does anybody have any questions about these specific regions? Okay. So we could also talk about different properties, metals and non-metals. Metals tend to have certain characteristics. Metals have luster. They're malleable, which means they can be beaten into a sheet. Think of a mallet. Ductile means they can be stretched into a wire, like the word duct, and they conduct electricity and heat. Metals have pretty much, well, they often have these characteristics. Now, non-metals are the opposite. There's no luster to them. They tend to be dull. They're not malleable, which means they're brittle, which means you bang it with a hammer, it'll split apart. They're not ductile because they're brittle again, and they tend not to conduct electricity or heat. We call them insulators. Now, we're not going to spend a whole lot of time on heat transfer here, but it is part of Module 2, at least as far as the homework goes. I don't think you'll see any questions on the test about this, but you will definitely see it in the homework. And we are going to get a lot more into heat capacity and stuff once we get into test 3. That's when we'll talk about heat capacity. But heat capacity is a measurement that gives us an idea of how much heat something can absorb. So for water, the heat capacity is 4.18 joules per gram per degree Celsius. What does that mean? It means that, see, joule is an energy unit, or a unit of energy. That's per 1 gram per degree Celsius. So it takes 4.18 joules to heat 1 gram of water by 1 degree Celsius. So one thing you've probably noticed is that it can often take a long time for water to boil. That's because it has a very high heat capacity compared to a lot of other things. So aluminum, for example, is 0.902 joules per gram per degree Celsius for heat capacity. It takes 4 times less energy to heat up 1 gram of aluminum by 1 degree. So 4.18 versus 0.902. So what does that mean in practical terms? It means that for the same mass of water, it's going to take a lot longer to boil it, a lot longer to raise the temperature to 100 degrees to boil it. Whereas with aluminum, you can put an aluminum spoon on a stove, it's going to heat up pretty quickly because it has a fairly low heat capacity. And that's really all we're talking about here. So a question that might be asked, and this is in the homework, how much heat would be needed? Well, actually, let's see. Let's go back to the question here. The heat capacity of water is 4.18 joules per gram degree Celsius. The aluminum heat capacity is 0.902. It takes less energy to raise the temperature of 1 gram of aluminum by 1 degree Celsius than 1 gram of water. So this could be a true-false question. And you can see that the reason that it takes less energy is because the heat capacity of aluminum is lower than water. So it takes 0.902 joules versus 4.18 joules. So that's how you can, you can just compare the heat capacities. That'll give you an idea. So if you're having trouble with that, with that concept, you come back to the soft chalk here and look at example 7, and you can get an idea of how the heat capacities can be used to make those kinds of comparisons. Does anybody have any questions? We can also talk about some certain trends in the periodic table, and there's three that we like to discuss. And those are electronegativity, ionization energy, and radius, atomic radius, size of the atom. So when we're looking at electronegativity, we're looking at a propensity for something, an element, to attract electrons in its most simplest form. It's based on a scale called the Pauling scale of electronegativity, which puts fluorine as being the most electronegative element. These noble gases tend not to want electrons, so we don't really consider them to be particularly electronegative. But fluorine is the most electronegative element. The least electronegative element would likely be Fr. That one doesn't want to gain electrons, it would love to give one away. But you can see that the attraction of electrons is going to increase as we go across a row. And that makes sense because the more protons we have, the more attracted the electrons are going to be to the nucleus. So I think that makes a lot of sense. And also the distance out from the nucleus affects electronegativity as well. So if the outermost electron is a long way away from the nucleus, and that's going to generally lead to something that's less electronegative. So if you were asked out of P, Z, N, and Y, P, Z, N, and Y, which one would be the most electronegative? It would be phosphorus because it's closest to fluorine. You can see where zinc is. Zinc is down here, and then you've got yttrium down here. So out of these three, P would be the most electronegative. Ionization energy is the energy required to remove the outermost electron from an element. And that means that the closer the electron is to the nucleus, the harder it is going to be to take it away. So what we find is that very big elements like francium here, which would love to give away an electron, has a very low ionization energy. Whereas something like helium, which only has 2 electrons, very close into the nucleus, also you'd be taking an electron away, which would mean that it would lose its nice octet. So this is going to take a whole lot of energy to remove that electron. So again, if we've got P, Z, N, and Y, let's see, where are they? I'll go back here. P, Z, N, and Y. The one with the highest ionization energy would be P, followed by Zn, followed by Y, for that reason. Does anybody have any questions so far? The last one is atomic radius, which is basically the size of an atom. And I think it makes sense that you can see that if we're looking at going up a column, we see the radius decrease. And this makes a lot of sense because every time we go up here on the column, we're losing an energy level. And that means it's getting smaller on that basis. So that's fairly easy to understand. But what looks a little bit counterintuitive here is that the atomic radius decreases going across the row from left to right, generally speaking. And the reason for that is because even though we're adding electrons as we go across the row, what's happening is we're also adding protons, and those protons are pulling the electrons in closer to the nucleus. Because we're not adding energy levels here, we're just adding electrons to the same energy level. And that tends to shrink it. It's also related to electronegativity as well. But as we see, helium will be the smallest of the elements, and francium here would likely be the largest. So again, if we've got P, Z, N, and Y, the smallest of those elements would be P, followed by zinc, followed by Y. Any questions so far? Okay. Now, I said earlier, gave you a preview of this earlier, that we can actually tell, given two elements, what kind of bonding we're going to see between them. And we can do that by looking at their difference in electronegativity. And this little diagram here sort of tells the entire story. If you've got an element and another element and you're trying to bond them together, what that means is there's going to be two electrons in between them forming that bond. Where those two electrons are will determine what kind of bond we're actually talking about. So we've got X and Y here. We've got two elements with two electrons here sharing them. That's forming the bond. If we're talking about ionic, then the situation is that one has given away an electron or more electrons to the other element. And that means that the electrons are essentially on the element that took the electron, which means that that's why we're getting it as a negative charge and a positive charge. The positive is actually the result of an electron lost, whereas the electron gained is giving a negative charge. And we can actually predict that was going to happen if we know what the electronegativities are of each element. So we can find a change or a difference in electronegativity simply by subtracting them. And you can see here that ionic bonds are usually going to have a massive difference in electronegativity of 2 or more. Polar covalent is going to be 0.3 to 1.9, and non-polar covalent is going to be 0 to 0.2. So I'll show you examples of each of those. The other thing that's important here, let me pull up this periodic table again. Periodic table. So you can see that electronegativity is going to be kind of like where they are on the periodic table. So if you've got sodium and chlorine, you can see where chlorine is, and you can see where sodium is. And the electronegativity difference is going to be massive between them because they're far away from each other. Whereas if we're talking about something like carbon and chlorine, look where they are on the periodic table. There's carbon, there's chlorine. They're a lot closer together. That means their electronegativity is going to be a lot closer together as well. So you can see that that's going to result in what I'm calling polar covalent. So the electrons are going to be between the two elements, but closer to the one that's more electronegative. And again, the way we can tell what's more electronegative is simply by looking at which one's closest to fluorine. And chlorine is closer to fluorine than carbon is, which means chlorine is going to be more electronegative. So that would be polar covalent. See, ionic, the electrons are on the element essentially. Polar covalent, sort of in between. And then you've got non-polar covalent, like between two elements, we're going to have an equal pull on the electrons, and there's going to be no electronegativity difference between them. So that's how you'll be able to tell. Does anybody have any questions?
I actually do.
Yes.
And this might actually kind of sound stupid. Do periods and rows have different, like one has a bigger difference than the other? Like if it was a difference between oxygen and chlorine.
Oh yeah. No, that's not a silly question at all. You'll see that there's these are fairly close, whereas O and S are going to be fairly far apart. So you can't just look at just pure distance. You've got to, you're looking at just regions really, and saying, well, if you've got something over here versus something over here, there's going to be a very large difference between them. Whereas if they're close together, there's going to be a small difference. That's really all I'm trying to say.
Yeah.
All right, so I think we'll leave it there for today. If anybody has any questions or anything about the course, you can always email me, or you can always call me as well on my phone. You've got my cell phone number in the syllabus. So I hope to see you all on a regular basis, and I hope to see you all doing the work you need to do to pass the course. All right, well, thanks for coming, and I will see you all on Wednesday.
Thank you, Professor.
Thank
All right.
you.
Have a good
Thank
one.
you.
All right, bye.
Good lab.
Thank you, Professor.
You're welcome.
Thank you, Professor. Goodbye.
Have a nice day.
Thank you. Haley, can I help you?